Most people try to heat their homes by heating the air. That is a losing battle. Air is a poor conductor and leaks out through every crack. Physics dictates that you shouldn't heat the space. You should heat the mass. Today, we're using stones, water, and density to create a thermal battery that keeps you warm long after the fire dies. When the power goes out, your instinct is to heat the room. You light a candle, you burn precious propane, you huddle in the middle of the living room. But you are fighting the laws of thermodynamics, and you are losing. Air is not a battery. It has almost zero capacity to store energy. It is a transport mechanism. When you heat air, it expands, becomes lighter, and rises. This is convection. You are paying to heat your ceiling. Meanwhile, the cold air from the floor, the heat vampire, is sucked in to replace it. Your house isn't a fortress, it's a sieve. Insulation doesn't stop heat loss. It only slows it down. If you rely on heating the air, you are on a treadmill. The moment your fuel source stops, the temperature crashes. To survive a freeze without electricity, you need to stop thinking about air and start thinking about density. Stop. Look at this. Air is the feather. Stone is the brick. Which one would you trust to hold a heavy load? Heat is energy. You need a heavy container to hold it. Stop trying to carry water in a sieve. This is where we talk about specific heat capacity. It sounds complicated, but it's simple. It's a measure of how much energy a material can swallow before it gets hot. Water is a miracle substance. It is dense. It absorbs massive amounts of heat energy. In fact, water can hold 4 times more heat energy than stone or concrete. This means a single gallon of boiling water contains more stored warmth than a pile of hot bricks. When you heat water, you are charging a battery. When you take that water off the stove, it doesn't just go cold instantly like air. It radiates. It releases that energy slowly over hours. This is the difference between a flash in the pan and a slow burn. So how do we use this? The most underrated survival tool isn't a knife. It's a stainless steel water bottle. If you have a heat source, a camp stove, a fireplace, or even a small fire outside, you boil water. You fill the bottle. You seal it tight. You now have a 200-degree radiator. Do not touch it directly against your skin. Physics doesn't care about your comfort. It will burn you. Wrap it in a wool sock. Wrap it in a shirt. Place this bottle at the bottom of your sleeping bag before you get in. It forces the heat to rise through the insulation, trapping it around your body, or hold it against your femoral artery near your groin. This heats your blood, which then circulates warmth to your fingers and toes. You are using your own circulatory system to distribute the heat stored in the water. A warning: if you decide to use rocks instead of water, listen closely. Do not pull rocks from a riverbed. Do not use porous stones. They contain trapped moisture. When that moisture boils inside the rock, it expands. The rock becomes a grenade. It will explode. It will blind you. Only use dry, dense granite or soapstone. If water isn't an option, use the earth. Stones are the oldest batteries in history. Place large, dry stones near your fire. Let them soak up the thermal radiation. You aren't burning them, you are charging them. Once they are too hot to touch wrap them in layers. Wool blankets, canvas, old towels, bring them into your shelter. A hot stone wrapped in wool is a heater that requires no ventilation. It emits no carbon monoxide, it just gives back what it took from the fire. Put one behind your lower back. Put one at your feet. You are creating a zone of heat that defies the air temperature of the room. The room can be freezing, you will be warm. This brings us to the most critical mistake: attempting to heat the whole house. When the grid fails, your house is dead. Stop trying to resuscitate it. Shrink your world. Build a microclimate, a tent inside your living room, a blanket fort over your bed. By reducing the volume of air you need to heat, your thermal batteries, the water, the stones, and your own body heat become exponentially more effective. In the 1800s, people used bed curtains. They weren't for privacy. They were to create a small, trappable air pocket that body heat could sustain. You don't need to heat 2,000 square feet. You only need to heat the 2 inches of air next to your skin. Imagine it's 3 a.m. The fire went out hours ago. The propane heater is empty. The air in the room is now 20 degrees. If you relied on heating the air, you are waking up freezing. But if you have a thermal battery in your sleeping bag, it is still releasing heat. It is the difference between sleep and suffering. This isn't a life hack. This is ancient engineering. The Romans didn't have forced air havoc. They heated the floors. They heated the stone walls. They understood that radiant heat energy traveling from a dense object to your body is superior to convection. Modern solutions like propane heaters are dangerous indoors. They consume oxygen. They produce carbon monoxide. They are silent killers. A hot rock consumes nothing. A hot water bottle emits nothing. They are chemically inert. In a sealed room, thermal mass is the only heat source that is 100% safe to sleep next to. Survival isn't about fighting nature. It's about understanding physics. The cold is relentless. It never sleeps. It never stops trying to reach equilibrium. If you try to fight it by heating the air, you will run out of fuel. But if you store the heat, if you bank it like currency in water and stone, you can outlast the storm. Don't be a consumer of heat. Be a battery. I've put a list of the best containers and materials for thermal banking in the description. Go check your gear. Do you have a plastic bottle that will melt or steel that will serve?